Hello, grade 10. I want to talk to you about the effect that a predator can have on a prey species. So here we have a population of mice who are living happily, eating lots of cheese and running around a barn that they all live in and just enjoying life, having a grand old time. Until one day, this big, huge, scary tomcat shows up and starts eating some of the mice. Well, life is not so good anymore. Prior to the introduction of the tomcat, there was a certain level that the mice population could reach, but not really get any greater than, right? Based on how much food they have and how much space they have, there's a certain amount of mice that could live in the barn happily, given how much food and how much size and space they have, right? Just like in your own house, there's only a certain number of people who can live in your house because you'll run out of beds and food will cost way too much and you'll run out of water and things like that, right? It'd be kind of crazy to have 30 people living in your house, and same thing with this barn. You can't have 1,000,000 mice. So this formula down here is called the differential equation, and it's something you don't really deal with in high school, but basically what it does is it shows how the population of the mice change as time goes on. So P represents the population of mice. This bottom value here, this 200, is the long-term stable population of the mice, given how much food they have, how much water they have. And that's without the presence of the cat. If the cat wasn't around, the population of the mice would probably stabilize around 200 as time went on. This minus H value is how many mice are eaten by the cat per day. And it's negative because the cat eats mice, and so that's going to decrease the population. And without going too much into the math, because it's long and boring, this top formula could be manipulated to look like this guy here, which looks like a big monster. And if you do this special kind of analysis on it, you can figure out how the population of mice will be affected based on the presence of the cat, depending upon how many mice are in the barn when the cat shows up. So that brings us to this graph down here, which basically shows how the population of the mice will behave as time goes on, given, and this is important, given how many mice are in the barn when the cat shows up. Right? If there's not enough mice in the barn when the cat shows up, the population will go extinct. If there's enough mice in the barn, they'll be okay. And this graph shows how that happens. So let's say the population started at around 75, and first things go really well, right? The population is increasing, and then they hit this blue line, which is a place where the rate of change switches. So they're still increasing, but not as rapidly anymore. And as time gets really long, into the weeks and into the months, you stabilize around this green line, which I've just called the population stability level. You'll notice that it's not at 200. And again, that's because there's a cat in the barn. If there was no cat, our green line would be up here, and life would be a little bit better for them. But because the cat is there, things aren't as grand. If the initial population when the cat showed up was greater than our stability level, say about 175. Again, as time went on, because of space and limited resources, the population level would still equalize down towards that stability level. However, if there were, say, less than about 50 mice in the barn when the cat showed up, I'm calling this the extinction threshold. If there was less than 50 mice, then the population would go extinct. So this is an important model for not only mathematicians, but also biologists and ecologists and just people who care about the environment. When people introduce a new species into a population, especially a predator species, it's important to know how that new species will affect the populations of everything that it eats. Because if the initial populations of prey are less than this extinction threshold, and that threshold varies depending on the species, but if the initial population of that prey species is less than the extinction threshold, there's a high risk that that population could go extinct. Right? So hopefully this shows you how mathematics is important not only for people like math and high school students, but also for people who care about the environment, such as biologists and ecologists, and people who care about the stability of species for a long period of time.